Hi, in this video I'll be giving a theoretical background on quadratic functions. I will also explain certain features on the general quadratic function equation, which takes the form y is equal to ax squared plus bx plus c. And I will also present some variants of this formula and explain their features too. So if you find quadratic functions hard, then this video is for you. And even if you already know quite a lot about these this function, then it should also be well suited for you, because I'll be covering the basics that you may have overlooked as well. So let's get into it. Amongst the features of this graph, we have the coefficient of x squared, this a here. So if we look at a, what does a tell us about the shape of the parabola? So basically, if a is greater than 0, in other words, if a is positive, that means the graph is going to be concave up. Positive is often associated with happiness, so it's more like a smiling function, where this part here would then represent this part here. And also, when a is less than 0, this means that a, of course, is negative. Then we would have a graph that looks like this. A negative graph is associated with a negative emotion, sadness, so it's a sad graph. That's what I used to call it while I was still in high school. So this is how you can remember the shape this graph will take depending on the sign of the coefficient of x squared, sign of a. Now let's look at another part of piece of information that's very valuable in this graph. The y-intercept of this graph, the y-intercept occurs where x is equal to 0. So basically the y-intercept is this place here. It's here. So this is the y-axis, this is the x-axis. So this is the y-intercept. The y-intercept occurs when x is equal to 0, because there x is equal to 0. This means that if you were trying to find the y-intercept of this graph, you would set every place here to 0. As a result, you will always see that y is always equal to c. So the y-intercept occurs at c. So that's the coordinate for the y-intercept. And the x-intercept, let me write it here. The x-intercept occurs at y is equal to 0. It could be a point here or here, but then it has to be in the x-axis. So let's just choose this one here. You can see here that y is equal to 0. So if, for example, you were asked to find the x-intercepts, you would just equate this graph to 0 and then solve for x and y. Usually you're going to have two values, but then sometimes you're going to have one value, or you're not going to have any value for x, depending on the nature of the roots of the function. Okay, now let's look at b. b tells us about the effect of, what's this? It's called the axis of symmetry. So b kind of like informs us about the effect it would have on the axis of symmetry, in the sense that, let me just remove this, in the sense that if we write out x is equal to negative b over 2a, which is the axis of the symmetry, you'll find that b is there. If you increase the value of b, provided that b is positive, of course, this and 2a remains constant, this simply means that you're going to have a certain value here. Let's say, for example, let's say you get negative 10 as your x. That negative 10 represents a value that would be taken by the axis of symmetry. The axis of symmetry would take negative 10. And then if you increase, let's say you increase this value maybe to 20, and then as a result it gives us 15 when we calculate our x, provided that the bottom is positive. Then this would give us 15. You see, a change in the value of b will give us a different value for the axis of symmetry. So the axis of symmetry is dependent on b, and b also affects the y value of the axis of symmetry. The y value of the axis of symmetry is 4ac minus b squared over 4a. You see, so if you change this value here, it's going to change the numerator and ultimately change the y value. In a nutshell, b affects the turning point, because the turning point is given by negative b over 2a and also by 4ac minus b squared over 4a. If this is not clear, it's actually this value here. So b affects the turning point. I will investigate how it affects the turning point in the next video when it comes to the y aspect, the y value of the function. Okay, now another thing that we have to observe here, because there's a lot that you need to know here. So another thing that you have to observe is what happens when a increases or what happens when a decreases. So suppose, for example, we were given this function. Suppose this function is y is equal to x squared. Let's say a is 1. So let me just remove this. Let's say a is equal to 1. Even if we don't write 1 there, the coefficient when we omit a value is assumed to be 1. So what happens when we now increase? Let's call this the function y sub 1, and then let's have another function here, 5x squared, and then let's have another function, say 20x squared. So here a is equal to 1, a is equal to 5, and a is equal to 20 here. So what happens when a increases? So if this is the standard graph, y1, let's call it y1, when x is equal to 1, the y value is also going to be equal to 1 there. If you substitute x is equal to 1 there, you're going to get a corresponding y value that's also equal to 1. As a result, there we have 1, 1. But then look at this function y2. When you substitute x is equal to 1 there, you get a corresponding y value of 5. This means that for the same value, you're going to have a point that's there. This means that your graph is going to look something like this now for y2. So this is y2. And also for y3, the graph is going to look something like this. So what we're seeing here is that as a increases, y and for any number for instance for like n1 2 3, so yn seems to be shrinking, so shrinks, or maybe let me just remove n here, don't want to confuse high school students. Let's just say as a increases, an arbitrary function y will shrink, given that it's of this configuration here. So that's what a does. So I want you to tell me in the comment section what would happen if we had a function that looks like this. What would happen to the function itself? Would it shrink or would it widen if we had something like this? You will start like this, and then you will go on to have a function that looks like this, and a function that looks like this. negative 20x squared. You should tell me what's going to happen here, and of course this is going to be 1. So is this graph going to be shrinking, or is it going to be widening a bit? Okay, let's go to another one.